Okay, so like I said, I'm just going to let you take a look at some of these ones, and I'm not going to go over all these details. And then a reminder that if you had missed your stuff on number 2, take a look at that part right there, because it is percent hair growth. Okay, that's a percent of the thing. So you had to multiply it out to figure out those numbers. Okay, so then, yeah, you know what else was nice on this one is that the assumptions and conditions were assumed to be met, so you didn't even have to do them on that. So hopefully you didn't do that. That helps to read. Okay, moving on. Um, so also then number 3 was a 1 proportion z-test, okay, and against the claim of it being 0.07. And so then we ended up rejecting the null hypothesis, and I'll let you take a look at that. And what I did want you to do 4, even though when a week or so ago when I kind of started having you do some review questions, you didn't do this one. I wanted you to go and do that one and fill that one in to compare the apple's parent strain to the new strain. And you can see from the answer key that I gave you. So since this is a comparison of 2 proportions, remember that we're going to have this written here. Okay, most of you did a good job of writing that on your quiz. So don't forget, if it's about 2 proportions, that you have to tell me which way you subtracted. And let's pay attention to this wording. Oh, here's another thing I saw that people messed up on their quiz. A few people, not everybody. Some people have an interpretation of thinking that this first number goes with like the new one and this second number goes with the parent one. And this is about the difference between them. This number means that when whatever the new number was minus the parent strain number, I got a negative value. And when I did the new infected proportion minus the proportion of the parent infected, I got a positive number. So these are about a difference. That's why it's about the difference in the infection rate. Okay? And then again, I keep it where it was 39% higher for the parent strain up to 5% higher for the new strain. And then on these, you also include the 0 statement. So when there's a difference, when it's a 2 proportion problem, you're including a 0 statement. Okay. And I'm just going to let you take a look at the answer key for 5. I want to start at number 6. So here we go. Okay, so this is, critical. On the test, there's 10 multiple choices and 2 free responses. And the 10 multiple choices have to do a lot with what I'm about to hone in on right now with you, okay? And then the 2 free responses, one of them is about intervals, and one of them is about hypothesis test, either 1 proportion or 2 proportion hypothesis test, okay? By the way, the one that is about intervals, it doesn't say just do a panic model. It'll ask you questions about, what about the sample size? What happens if we make this larger? What happens if we make this small? I mean, it'll ask you more in depth questions, not just do a panic model. Okay? All right, so let's then focus on this. So number 6 says, what would give you a bigger confidence interval? Okay, so the key is knowing this, that it's your margin of error that is the key to the size of your interval, okay? Where is the margin of error in that formula right there? Good. It is the margin of error is the part after the plus minus. The margin of error is that part after the plus minus. So if that thing's changing, then your interval size is changing. So since this Z star has to do with confidence, okay, I want you to think about that. 90% confidence would have that much in the middle. 99% confidence would have that much in the middle. So as you get more confident, you are more confident that you captured the true answer. So more confidence does what to your interval? Make it get bigger. So that applies to statement B here. Statement B keeps the sample size the same, so that's not the issue. It's about which is bigger, a 99% confidence or a 90% confidence, and which one would be bigger? 99, because you are more confident that you captured the real answer. All right, now Part A focuses on, it keeps the confidence level the same. 95% confident is the same for both of those, but it references sample size. One is 25 and one is 75. So I want you to think about this. What would you feel more accurate with estimating the population? A smaller sample size or a bigger sample size? What do you think would make you feel more confident about your estimation? A bigger sample size would make you feel better. Probably shouldn't use that word confident, but it would make you feel like you're a little bit more accurate and you're more focused in on your estimate. So if n gets bigger, then you're got a smaller variation. You got smaller variation. So which one gives a bigger confidence interval? A smaller sample size. That's it's kind of loosey-goosey. You're not feeling so good about a smaller sample size because it's giving you a big old interval. Okay? All right, questions on that? All right, I didn't actually even want to go over really numbers 7, 8, or 9, or 10. I think that those are, I expect you to, I'll give you time here in a little bit to read over those, okay? But I didn't think they really took much discussion. So, moving on. I do then want to start at number 12. So let's go on over to number 12. By the way, I did want to remind you, even though I'm not going over this, that of course there will be questions about changes and how they affect your error, your type 1 and type 2 error. Okay, so remember this picture that I made you draw? And this helps you remember as n goes up or alpha goes up, what's happening to the power even. Okay, so then of course while I'm looking around, being a nerdy person researching stuff, then I found this meme here. So let's look at it. I heard you upped your sample size. More power to you. Okay, so there is our thing. See, look, I heard that you upped your sample size. More power to you. Okay, all right. So there's that. You got to get the little chin nod or chin jerk in there. Let's go ahead and move on to number 12. So here we go. All right. So if you are told in a problem a margin of error, I can almost guarantee you need to set up this part after the plus minus. The part after the plus minus is your margin of error. Set that up as a formula. Okay? Furthermore, a mistake that I have seen in the past is I have seen people see this. 0.95 is the confidence level, and don't do this, but I have seen some people say, oh, the z-star is 0.95. Okay, that's not it. We know that when you are given a confidence level, that is the amount in the middle. Okay, so then you have the tail, 0.025. That is where your critical value comes from. Your z-star is inverse norm of 0.025. Okay, now then let's remember this little thing. If you have true p, that's the best it can be, and you should use true p. But if you don't have that, then what? You should use p hat. But if those don't jive, please don't cry. You're going to use 0.5. Use 0.5. Not to be confused with alpha, which is 0.05. Thank you. Okay? So this is 50%. 50%, not 5%. 0.5. And then, of course, 1 minus 0.5 is the other 0.5 here. Okay? So that's where those are coming from. So we set up our equation here, and then I got 267 policyholders. Now, let me tell you how the AP exam, because depending on where you round and depending on how big some things are, it can make a big difference. Even like on the top of page 14, a lot of people were getting 1509. I got 1503. So here is how this, a little bit of being off on the sample size will be handled. Here's the way the question will be worded on AP and for me. Okay, you ready? Here it goes. What is the minimum sample size needed in order to meet those requirements? In order to, so that it differs by, sample proportion will differ from the true proportion by less than 0.06, okay? So what's the minimum size needed? So I do my math, and I go, oh, I need to have at least 267. So here is your multiple choice. See, look, I set up a little multiple choice question over here for you. Is A, 100 acceptable? Going to meet the requirements? No. Is B, 200 going to meet the requirements? No. Is C, 300 going to meet the requirements? Yes, ding, 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 because I need at least 267, so 300 does the trick. Okay, 400 is bigger than that, so the minimum amount needed to meet the requirements. Okay, so that's how it kind of covers up that some variation in that. Okay, yes ma'am. Good question. I get questions. Do we need to now do the Z? Oh, on this one? Yeah, actually, no. Yeah, since you know the calculator trick, you don't have to show all the work anymore on even the one proportion stuff. Okay. So, moving on. Question number 13. Question number 13 is asking for what level of confidence. Okay, so here's the thought process I would have gone through when I see this question. Okay, number one, I'm thinking, okay, a couple things. I'm like, okay, level of confidence. Well, you know, I'm a picture person, so level of confidence is always that part right there in the middle, you know. It's this area that I put down here in the middle. Okay, so that's one thing my brain is thinking. Here's another hint. The other thing your brain should be thinking is, oh, hey, guess what? They gave me a margin of error. Huh. If they're giving me a margin of error, then I probably need to be setting up something in this format here. Okay, I bet you somehow that's going to be needed. Okay, so there's you a little hint strategy. So, indeed, if I see that I want to find this area in the middle, I need to go from a Z star down here to a Z star up here to compute norm CDF this area, and that will be my confidence level. So I got to get those Z stars. So here I go. I'm going to fill in all my information. You know, even if you're just blindly kind of just filling in information, I get everything filled in from the problem except for the Z star. Man, that just works out great, doesn't it? So then when I do my math and I solve, I get a Z star of 1.8. That's telling me that my interval is going to be going from negative 1.8 Z star critical value up to positive 1.8 critical value. So those critical values are those edges of your interval, Z values. And I norm CDF from negative 1.8 to positive 1.8, and I get about 93%. Okay? All right. So again, if they're giving you margin of error, then you should immediately think, ooh, hold on, I might need to be using this here. So let me think about that. Okay? All right, moving on. Number 14 is just like number 12 in that you are asked to find the sample size. So you do that. Now, how many of you guys used a critical value of 2.33? And I used 2.326, see, which I probably should have just used 2.33 because they probably just go to two significant digits. How many of y'all got 1509 students? See, that's fine. I had done it and see how I got a little bit different? That's why, as a multiple choice question, it's going to be worded something like this. What's the minimum amount of students needed in order to meet the requirements? Or in order to be 98% confident within plus or minus 3 percentage points. Okay, so if I need 1503 or 1509 or whatever it is you're saying, is 1,000 enough? No. Is 1450 enough? No. Is 1600 enough? Yes. Okay, so that's how they handle that variation that we get with those numbers. I'm not going to really go much over 15. I think I talked to you about that yesterday when you were going over stuff, but you can see your anatomy, your p-hat is right there in the middle of your interval and so on. And then number 16, your p-value is the probability of getting this sample or something more extreme if the null is true. Okay, so that's just formula. 17, lots of people had questions on, and this is a very important concept, so let's talk about 17. So here's what happens. On 17, you go take a sample and you make an interval. Okay? We go take a sample, we make an interval, and we get this number 0.793 to 0.851. Well, you know, you're not allowed to do an official rejecting or failing to reject with an interval. So you're going to go have to run a test, okay? If they say that the null hypothesis is 0.86, what do you think, before you even run it, what do you think is probably going to happen when you go run a test against the null hypothesis 0.86? What are you going to think is going to happen to it? What? You're going to reject it. Why will you reject 0.86? Because it is not in your interval. If I was to hypothesize about the value of whatever this is, I think it's probably actually what? 0.86. Higher, lower, equal to what? Lower, because my entire interval is below the 0.86. Of course, I can't say equal to, because that would be a bad saying null is 0.86, or null is true. I think most people were fine with 18, but number 19 is important concept, so let's stop there and talk about this. 19 is important. Here we go. Okay, so the thing to recognize on number 19 is that it says, gives you your null and your alternative, and then it says at the 2% level. What does 2% level mean? 2% significance level. What does that mean? That's your alpha. That's the size of your rejection region. So 2% significance level is your alpha, the size of your rejection region. So that's important. I got 2%. That's my rejection region. But the alternative is important. This tells me that my alternative is two-tailed. So I have that 2 percentage points split amongst two tails. So since I have it split amongst the two tails, 1% is going in each tail, therefore 98% confident is the confidence level that was used. Okay? Now, I do want to point something out to you. Suppose that this problem had said the alternative is P is less than whatever. Okay? Say it had said it's a one-tailed, lower-tailed problem. Then where would the full rejection be? Down here. The full 0.02 would be in this lower tail. If the full 0.02 is in this lower tail, mirror image would put it up here, meaning the confidence level is 0.96 or 96%. Do you see how the tail could change your value of your confidence? Okay, so that's why paying attention to the tail being used is important. Okay. Let's go ahead and reinforce this, because number 23, which I saw a lot of people asking questions on, is the same concept. So let's skip over there, and then we'll come back after that and do number 20. So pop over to number 23 real quick. All right. So number 23 asks for critical value. So first of all, people ask me, what's critical value? Well, that's that Z star. That's that standard deviations of that placement, such that this rejection region is where you put it. Okay. So they say rejection region is 12%. So next, it matters where it's located. Part A gives you an alternative that says it's an upper tail problem. One-tailed, upper-tailed. So the entire 12% is in this upper tail. That puts your critical value that separates these two sections as inverse norm of 0.88. Okay, so that's how you get that one. Whereas question B gives you an alternative that is one-tailed, lower-tailed. One-tailed, lower-tailed puts the entire 12% down here, so that means the location of this critical value is an inverse norm of 0.12. So that's at the negative placement of that. But with question C, with part C, it gives you a two-tailed alternative. Therefore, the rejection region of 12% is split between the two tails. And having that rejection region split between the two tails puts you 6% in each tail. So you have two critical values, one down here at negative 1.56 and one up here at positive 1.56. Okay? All right. Okay. So let me then go back to the previous page and finish out the one I hadn't done. I just kind of wanted to keep some like problems together. So down here to this one, B, we kind of talked about that. Do you think you would reject or fail to reject if this is your interval? And that one was, I'd probably fail to reject because 20% is in my interval, so I wouldn't have evidence against it. Okay, and then you know what? I got lots of questions yesterday about number 20. And it's actually a very simple problem. I think what caught people up is the vocabulary of what number 20 was asking. So guys, when it's saying sample proportion, that's just your p hat. Okay, so that means they want to know what the p hat was, and you know, based on an interval, the p hat falls smack dab in the center of your interval, because you do p hat and then margin of error up and margin of error down. So when it asks for the sample proportion, that's smack dab in the middle of your interval. Okay. If it had asked for margin of error, of course, then that would be this section here. That would be this distance. Okay, moving on. I love number 21. I see this one many times, several times throughout the year. Okay, this is a good AP problem. Good, good, good. Okay, the first key to this number 21 is understanding what the first statement is saying. The first statement says, you have statistically significant results at the 10% level. Statistically significant means you got something out there in the rejection region. You got a sample out there in the rejection region that gave you a p-value that was lower than 0.10, so you rejected. Statistically significant. Okay, so here's a picture of what that means. That means I got a sample out here in this upper 10%. Okay? Well, if you're significant in the upper 10%, does that mean you are in this top 5%? Not necessarily. You could be, but you are not necessarily in this top 5%. Okay? And then, but if you're in the top 10%, are you in this top 20%? Yes, you are definitely in the top 20%. You know, think about it in terms of your class rank. If you're in the top 10%, does that mean you're going to be in the top 5%? Not necessarily. But if you're in the top 10%, are you in the top 20%? Yes. Okay, same thing. And then 22 is just kind of like a formula question. And then 25 is one where it's a problem. I want you to just look at the answer key and go through those things. And I wrote the conclusion on the next page and such. So, any other questions? I want you to take some time right now and go through those wordy problems at the beginning that have lots of things. Yes, ma'am. Yeah. What happens is you'll do the P, the A, the N, and when it comes to the I, you don't have work, you just have the interval there. Yes. All right, so that's that.